Okay, now let's discuss the median of a probability density function. So when we're looking at median, what exactly does that mean? Well, median sounds like middle, right? Well, the median accounts for where 50% or half of the values in a probability density function fall. That's why when we look at what's given, we're looking at two separate integrals here. We have the first one on the left, negative infinity to m, of f of x dx equals to 1/2, and then we have the other side, the flip side, which is m to infinity of f of x dx equals half. So this is where, either on the left or the right, half of all values of a probability density function exist. All right, so what we're going to do is we're going to find that middle value. We're going to be solving for m in this case. All right, so what we're going to do, we take this f of x equals, and it's 8 over x squared from between 1 and 8/7. It's 0 otherwise, but we really won't concern ourselves there with that one. So we're going to look and see, well, if we're starting off at 1, if I integrate my function from 1 to some value m, the median, and it's 8 over x squared dx, where does it equal 1/2? In other words, what value of m will get me to 1/2? So what I'm going to do here is I'm going to take a look at this first functionally. 8x to minus 2 dx, all right? I rewrite it algebraically rather, all right? And now I'm going to actually integrate. So I add 1 to the exponent, I get 8x to the minus 1 divided by -1, or in this case multiplied. And what does this give me? This gives me a -8 over x. So I'm going to utilize that. I've already integrated it there, done the hard work. -8 over x evaluated from 1 to m should equal 1/2. So I've basically created an equation that I can solve now for my value m. And that is to say that I have -8 over m, right, minus a -8 over 1, which just becomes a +8. And I set that equal to 1/2. Okay, so I need to subtract 8 from here. All right, and that cancels that out. I end up with -8 over m equals 1/2 minus 8 is going to be -15 over 2. It's -7.5. So I'm going to write it as -15 over 2. And then my job is going to be to solve for m. All right, so I know because I'm dealing with a negative and a negative, my answer is going to be positive. So basically, I can cross multiply and divide kind of. So I end up with an m equal to 16 over 15, if you will. So I'll leave you to figure that out for yourself, but it's really not that hard to understand. All right, now let's go ahead and take a look at another one, one last example of the median. So we'll call this one number 10 here. We're looking at the function f of x equals 1/7 x over the interval from, let's say, 0 to the square root of 14. Rather interesting interval. But, here's our PDF. We're looking for the median. So we're going to integrate from 0 to m, 1/7 of x dx. All right, so what does that look like? Well, we set that equal to 1/2. All right, this isn't too bad of an integral because it's just 1 over 7 and then it's x squared over 2. So we end up with 1 out of 14, if you will. 1 out of 14 x squared evaluated from 0 to m in this case, and we set that equal to 1/2. All right, now when we've done that, we have 1 over 14 m squared minus basically what works out to be 0 equal to 1/2. All right, so we really don't concern ourselves in this case with the 0. We can multiply both sides by 14. That has the effect of getting rid of the fraction that we were dealing with, and 14 over 2 is 7. So in order to find out what m is, all we need to do is take the square root here. So we can say then that m equals the square root of 7 in this example. All right, so a couple of examples here on how to find a median. Again, it's really not that difficult. All right, you start off with this principle of setting the integral equal to 1/2 and solving for m, the median. All right, as always, I hope this video was helpful, And remember, like and subscribe.